Let M be a 3 by 3 singular matrix and suppose that 2 and 3 are eigenvalues of M. Then the number of linearly independent eigenvectors of MQ plus 2M plus I is equal to. We have to find number of linearly independent eigenvectors. Number of linearly independent Li. It means linearly independent eigenvector. Eigenvector. How to find number of linearly independent eigenvector? If we know rank, then we can easily tell about nullity of matrix by rank nullity theorem, because singular matrix, it means M of size 3 by 3, its eigenvalues, because of singular, one eigenvalue is 0 and two other eigenvalue it is given to us. 0 is indirectly given and 2 3 directly. You can see 0 2 3, these are eigenvalues and these are distinct and real. Real has no significance here, but distinct is very significant. Because of the distinct eigenvalue, matrix M is diagonalizable. It means algebraic multiplicity of each eigenvalue. It means lambda I, our and I varies from 1 to 3, means lambda 1, lambda 2 and lambda 3. Lambda I may be anyone from 0, 2 and 3. So algebraic multiplicity of lambda is equal to geometric multiplicity of lambda i's, and these are equal of for each eigenvalue. So we have to tell about M3 means m raised to the power 3 plus 2m plus identity matrix of correct size. Because of this is 3 by 3. So addition will be possible when these three matrices are same type or compatible for addition. But it is not our concern it is compatible or not. Everyone know about this fact. We come to the point, linearly independent eigenvector for this matrix. It means we have to know about geometric multiplicity of eigenvalues of this sum of matrices. As we know, eigenvalues of M are 0, 2 and 3. Eigenvalues of M are 0, 2 and 3. So eigenvalues of MQ will be, if lambda is eigenvalue for a matrix M, then lambda I raised to the power n will be eigenvalue of M raised to the power n when n is coming from set of natural number. Also scalar multiplication, this rule hold. If lambda is eigenvalue of M, then C lambda I will be eigenvalue of C times of matrix. So eigenvalues of MQ will be 0, 8 and 27. Eigenvalue of 2M will be 0, 16, not 16, 0 and 2 2s are 4 and 2, 3 2 is 6. This is 4. This is 4. 0 4 6 and eigenvalues of identity matrix we know 1 1 1. So eigenvalues of sum will be 1, 13 and 33. These are distinct eigenvalues of MQ plus 2M plus identity matrix. Eigenvalues of this matrix is 1, 13 and 33. It means each lambda I are distinct or is distinct. So this matrix is also diagonalizable, and diagonalizable matrix has algebraic multiplicity equal to geometric multiplicity of each lambda I. For each lambda I, it means each eigenvalues has geometric multiplicity 1, because this is 3 by 3 matrix. The size of this matrix is 3 by 3 and 3 distinct eigenvalue. So each eigenvalue has geometric multiplicity 1, and for each eigenvalue there exists a distinct linearly independent or distinct eigenvector, and these eigenvector will be linearly independent. So number of linearly independent eigenvector of this sum matrix means m cube plus 2m plus I will be 3.